Everything you need to know for APCSA Unit 1, Primitive Types. Starting now. A variable is used to store a value and allows us to refer to it in a program. Each variable has a name that follows standard naming conventions and an associated data type. There are two kinds of data types that variables can have. Primitive data types are essentially numbers and true-false values. The three primitive types that we'll only be using are int for integer values, double for real numbers, or basically a number consisting of a decimal point, and Boolean, which is either true or false. Reference data types define objects in memory rather than holding an actual value. These include strings, which utilize double quotes to define a sequence of characters otherwise known as string literals, objects of classes, and data structures such as arrays and array lists. To print or display information to a console, we can use system.out.print or system.out.println. The difference between these two is that print stays at the end of the current output, while println adds a new line after each output. Arithmetic expressions can be used on values of type int and double. These include the four basic math operators as well as modulo, which calculates the remainder of a division. PEMDAS rules still apply, and dividing by 0 is not allowed. An arithmetic expression that uses two int values will evaluate to an int, and an expression that uses two double values will evaluate to a double. If the expression uses a combination of an int and a double, implicit casting takes place where the result will be a value of type double. Explicit casting can be used to convert an int to a double, which simply tacks on a 0.0 at the end, or a double to an int, which gets rid of the decimal point and all digits to the right of it. If we want to round a positive number of type double to the nearest integer, we can add 0.5 to the value and cast it to an int. For negative numbers, we just have to subtract 0.5 instead. Values of type int must be in the range from its defined allocated minimum value to its maximum value. If an expression evaluates to an int value outside of this range, an integer overflow occurs and the result is an int value in the allowed range, but not necessarily the value expected. A similar event occurs for values of type double, where if an expression evaluates to a value that's more precise than what can be stored in the allotted amount of memory, a round-off error occurs. To avoid this, it's best to use int values. The assignment operator can initialize or change the value stored in a variable. It takes in an expression on the right side, evaluates it to a single value, then stores it in the variable on the left side, ensuring that it matches the variable's data type. If you want to use variables in an expression, they must have been initialized with a value beforehand and must be type compatible. Compound assignment operators evaluate an arithmetic operation using the variable's value on the left side of the operator and the value on the right, and stores a result in the variable on the left. The post-increment and post-decrement operators are used to directly add one and subtract one from the values of numeric variables respectively and saves the new value to the variable. Variables can be used to develop algorithms, which completes a task by following a step-by-step process completed one at a time from top to bottom. Before code can run, the compiler checks it for errors such as syntax and type errors, which need to be fixed if they are present in the code. A runtime error can occur if there's a mistake while the program runs, and causes the program to terminate. An exception is a type of runtime error when the compiler doesn't catch an unexpected error. Even if our code runs successfully, we can have logic errors where the algorithm behaves incorrectly. So make sure all types of errors are resolved so that an algorithm works as intended.